Hi everyone, my name is Sana and I'm the Vice President of the Google Developer Student Club at Carleton University. We are here today with Tanmay Bakshi, Google Developer Expert in Machine Learning, to show you how to augment songwriting using machine learning. Take it away, Tanmay.
Wonderful. Thank you very much, Sana. Hi, everyone. My name is Tanmay Bakshi. I'm really excited to be here. Thank you very much for joining in today. As Sana mentioned today, I'm here to talk about the world of machine learning, artificial intelligence, deep learning, whatever you want to call it for now. We'll get a little bit deeper into the terminology in just a moment. And before I get into that and sort of how I'm working with machine learning in all kinds of domains, all the way from augmenting developers to songwriters and using it for fields like authentication and so much more, all these really fun examples. I do quickly want to start off by telling you a little bit more about why I'm here today. So let's go ahead and get started. So I'm sharing my screen, and really quickly, just sort of start off. I mean, as I mentioned, I absolutely love the world of technology, right? Technology is something that I've always been really passionate about. In particular, there's three things that I absolutely love doing. First of all, I love building technology. I'm a developer at heart. I love creating new sorts of techniques to solve problems. Both from a technical perspective and also applying it to help people, as well as enabling more developers to do the same. So creating resources and content to enable more developers to solve problems they see in the world as well. And from there, making more people that aren't in the world of technology aware of the kind of impact that technology has on their lives. Because I feel like with how deeply ingrained technology is in our lives today, it's really important that we understand the kind of impact that it has and what its role really is. Now, I personally got into the world of technology something like 13 years ago, back when I was 5 years old. I mean, as a curious 5-year-old, watching my dad code all day was something that was really fascinating. And so I wanted to learn more. Of course, my curiosity, only grew every time a question was answered. So I started to use, different books and the internet as learning resources. And I started to learn different kinds of technology, like Visual Basic, and even how to build iOS applications. As a matter of fact, when I was 9 years old, I had my very first iOS application called T-Tables accepted into the Apple App Store, an application that helps you practice your multiplication tables. Now, of course, this application was designed to help people, but I also slowly started to realize that not only can I, of course, build applications that help people, I can also build resources to help people build their own applications as well, right? And so that's why I started my YouTube channel called Tanmay Teaches, where I upload tutorials on all kinds of topics from machine learning and programming to math and science and so much more. Now, when I started to upload these tutorials, at first it was just because, I wanted to help people. Potentially, if someone was interested in maybe learning how to code or solve a particular problem. But I slowly started to realize, as people would reach out to me, that there really are a lot of people that need help, that are stuck when they're trying to solve problems with the power of tech. And so to scale up the number of people I could reach out to, I also authored 4 tech books in the past couple of years, ranging all the way from learning iOS app development for kids and beginners to learning back-end development in the Go programming language, things that I'm, once again, really passionate about. So as you can tell, I've always been excited by technology. But back when I was around 11, technology almost got a little bit boring for me in a way, but not maybe in the way you think. Really, it was because I felt like technology was almost kind of limiting, right? Because technology is super rigid. It only really does what you explicitly tell it to do. And I found that kind of an annoying limitation, right? And so I thought, for the longest time, that there was very little you could do with technology when it came to decision making. But one day, I stumbled upon a documentary that fundamentally changed the way I thought about the world of computing. And it was a documentary on how IBM Watson played and won the Jeopardy game show back in 2011. This absolutely blew my mind, right? It sort of opened me up to this whole world of what computers can do that I didn't realize they could before, the world of machine learning and artificial intelligence technology. I mean, even today, it still fascinates me that we can take natural language complex enough that even humans have a hard time understanding it, and so quickly sort of analyze it with the power of computers. That it's still one of my favorite applications of machine learning to date. Now, when it comes to the world of artificial intelligence today, I think there are a couple of key limitations when it comes to artificial intelligence, or a couple of issues, rather. One of them is actually really fundamental. I personally don't like the word artificial intelligence, right? When it comes to AI, I don't think we should call it artificial intelligence. Instead, I think a term that's more true to the actual technology that we call artificial intelligence is more relevant. Like, for example, machine learning. AI is almost like a user experience term as much as it is a technology term today, right? So think about, for example, the Apple Watch, right? The Apple Watch does fall detection. So if I were to take a fall right now, it would probably detect that. And it would help me, for example, call emergency services if I can't respond in 60 seconds. However, while this is powered by machine learning, while it's taking accelerometer and gyroscope data and analyzing it in real time, we don't really call it artificial intelligence. It's very similar technology, though, applied to, for example, a humanoid robot to do text-to-speech, we suddenly start to call that artificial intelligence. And that's why I don't like it as a technology term. I do believe it is a little bit misleading. But that does not take away from the fact that it is undeniably an incredibly impactful technology, right? For example, 72% of organizations actually vote machine learning as the most disruptive technology out there today, right? And I find that very fascinating because there's other really talked about technologies right behind, like cloud and blockchain and IoT and so many others. Why do 72% of organizations, an overwhelming majority, vote machine learning as the most disruptive? And I found a quote that I think very nicely summarizes why machine learning is so impactful. It's because of the effect it will have on existing processes and the way people will work. Now, this is a quote from a mystery entity. I'll get back to who it's from towards the end. So make sure you remember this quote because of the effect it can have on existing processes and the way people will work. I need you to keep that in mind. And you'll see why in just a moment. But I want to dig a little bit deeper into this quote first. What does this really mean? Well, what this means is because of the fact that technology is infrastructure, machine learning is incredibly impactful. What does that mean, though? Well, if you think about it, technology is, of course, its own industry, but it's also pretty much universally applicable. I would be very hard-pressed to name a single industry that isn't fundamentally backed by technology today. Like the modern versions of these industries are all backed by the technology industry. It is the infrastructure for everything else we do. Think about healthcare, right? Healthcare is fundamentally powered by technology in so many ways these days. Think about education and how, for example, now during the pandemic, we've been doing virtual learning. And even before that, integrating technology into the classroom. Think about agriculture, how we're making things so much more efficient, how we're allowing us to use less resources and get better yields with the power of technology. How we've been using brand new kinds of technology in the field of entertainment to create media that we could have never created physically before. Think about finance and how people can trade with each other across the world instantaneously now, even on decentralized platforms like blockchain platforms and so much more. And what's really interesting is that when you take a look at all these different use cases, you start to notice that there are certain technologies that are less applicable in some than others, and that makes sense. That's natural. Technologies have their sort of use cases, right? So for example, in agriculture, maybe you want to do more edge computing than cloud computing. Maybe it doesn't make sense to use the cloud as much. Or maybe within the world of entertainment, you don't really have that much of a use case for blockchain. Or maybe within the education field, you don't have as much of a use case for IoT, right? So there are specific areas where technologies can and sometimes aren't as helpful. But what's really fun, I find, is that machine learning is practically universally applicable across all of these domains. You could probably find a use case in any one of them. And the reason, in my opinion, is incredibly simple. It's because when you boil away all of the hype, machine learning effectively becomes really fancy data analysis. It's pretty much all there is to it, right? You've got input data, you've got output data. You want to figure out a mapping between input and output, and machine learning helps you figure out that mapping. And it's incredibly useful what you can do with this technology. As a matter of fact, I've built really fun projects that leverage the power of this data analysis. And I want to start off by showing you one of my favorites, a project that I like to call Heart ID. It's a project that enables me to use machine learning technology to identify you based off of the way that your heart beats. What does that mean exactly? Well, there's two stages to the way that Heart ID works. First of all, I'm able to take electrocardiogram data, the electrical activity of your heart, the actual electricity that your heart produces as it beats, and store that data within a database after analyzing it with a neural network. Now, what that means is I'm able to take a deep learning system that I've trained, extract unique features from your heartbeat, and store those features in a database. Then, given new electrocardiogram that I may have never seen before, I can once again extract similar features, compare them to the ones in the database, and try and figure out who it is that's trying to authenticate, or if it's even someone from the database or not. It's really fascinating taking a look at the outputs of this neural network. For example, here are the bar graph representations of the features that the neural network extracted for electrocardiogram from me and my sister. So if you take a look at the actual bar graphs, these aren't like actual pieces of heartbeat data. This is not electrocardiogram. This is the neural network's internal sort of hidden state, how it looks at almost our electrocardiogram data. And I'd love to go ahead and show you a demo of Heart ID in action. As a matter of fact, taking a quick step back, Heart ID actually works in some cases where even, for example, Apple's own Face ID technology doesn't, which I find absolutely fascinating. As a matter of fact, a little while ago, two of my friends, Raquel and Simone Oatspear, reached out to me, and I found out that they can actually unlock each other's phones through Face ID. They can trick Apple Face ID. After only having been trained on one of them, their phone can be unlocked by the other. Take a look at this. I find this an absolutely fascinating demo because it's actually quite rare. So as you can see, Simone can unlock her phone with Face ID, but so can Raquel. But there's only a single identity set up within Face ID settings. So they were able to trick Face ID, but I'm glad to say that they weren't able to trick Heart ID. Let's take a look. So after capturing a couple seconds worth of data from Raquel, electrocardiogram data from her wrists, my system can correctly identify her as Raquel using those unique features that we stored in the previous stage. And similarly, given a couple of seconds worth of electrocardiogram data from Simone, I can successfully identify her as Simone. And that is a quick demo of Heart ID in action. This is the sort of capability that machine learning gives you, right? This is incredibly complex data where humans are unable to manually extract these kinds of patterns, right? We can't look at electrocardiogram, at least in the majority of cases, and just see, and just sort of tell based off of how the electrocardiogram looks, whose electrocardiogram this is. But with the power of machine learning technology, you can analyze incredibly minute patterns within very large quantities of data in order to computationally figure out what those patterns might be if we're unable to manually create the functions to extract those patterns. Or that's effectively what it boils down to. If we can't write a mathematical function for something, why don't we just have the machine write it for us? Right? That's sort of the goal behind machine learning tech. And I've found personally that across all the different domains where I've implemented machine learning, there's one that I'm incredibly excited about over pretty much all the others, and that is the field of language. You might wonder, why does language fascinate me so much? Well, it's because language is incredibly sort of inherently human. It is one of the things that sets us apart from pretty much every other animal on the planet, right? The fact that we can take incredibly open-ended thoughts and encode them in this sort of scheme where there's high enough fidelity for people to take abstract concepts and just understand them is incredible to me. I absolutely love the idea of language, and especially being able to process it and understand it with computers. As a matter of fact, one of my favorite examples of why language is so fascinating is the classic telling between different shades of the color blue, right? So did you know that if your first language is Russian versus, for example, English, you are actually statistically more likely to be able to successfully tell the difference between similar shades of the color blue? I know it sounds weird, but it's actually true because Russian just has more words for the color blue than English. So your eyes and your brain are fundamentally better at telling the difference between blues because you've had to do that because of the language that you speak, right? So taking a look at an example like this one, quite obviously in this case, the different shade of the color blue between A, B, and C is B, as you could probably tell. Maybe a little bit of a harder example, right? I'm not sure if the screen share compression probably makes this a bit of a worse example, but if you take a look at A, B, and C, even though these are closer, you can probably still tell that C is the different shade. Similarly over here, right? Getting a lot closer, but in this case, B is the different shade of blue. And finally, this one's a bit more of a toughie. I actually know someone who wasn't able to tell the difference in this one. First language was not Russian. funny enough. And in this case, the different shade was A, right? And so if your first language is Russian, there's a higher chance that you would have gotten these all right. And the fact that not only does the brain help us structure and create language, but the fact that it also goes the other way around, right? That language and what you speak can actually change the way that you think and physically change the way that you perceive the world is once again absolutely fascinating to me. And I want to know more about this world computationally. As a matter of fact, what makes language particularly difficult to deal with when it comes to computers is that, once again, it's encoding our thought process. And what that means is that it's possible, for example, to have language that is technically valid language, but that doesn't really connect to anything that we think about. Right? So it's hard to come up with rules. For example, the famous example, I believe, from Noam Chomsky is colorless green ideas sleep furiously. It's a simple sentence that means nothing, right? You read this, and off the top of your head, there's nothing that you can really think of from this, right? This doesn't really convey much of a thought to you. But at the same time, even though it doesn't really make sense, it is still a valid English sentence. You can parse this into a dependency tree like this. You could do this computationally. You could feed this in through NLTK, and it could give you this kind of dependency tree, right? This is a grammatically valid English sentence. Whether or not it makes sense is a different matter, though. And so artificial intelligence or machine learning technology today is powerful enough to be able to give us the ability to understand this kind of data computationally and understand, for example, if we could answer the question, does this sentence make sense? And if so, what does it mean? Can we translate it? Can we classify it? Can we do so much more? But because artificial intelligence technology is so powerful, I've noticed that it's also one of the most misunderstood technologies on the planet. Right? There's all this bias that we have as to what AI is or isn't capable of, or where it's going in the future. I mean, the first thing you probably think of when you hear AI, or the vast majority of people, at least, especially the ones that aren't in the sort of tech community, would be something like, I don't know, the Terminator, right? And this sort of thing that you associate with artificial intelligence. And some of the more sort of grounded misconceptions behind machine learning might be, for example, that we're trying to simulate human intelligence. That's not the case. We're not here to simulate the same sort of human intelligence that we've got. As a matter of fact, we don't know how to do that. Rather, what we're trying to do is take certain abilities that we have that we don't necessarily understand how we have, like our natural language understanding capabilities, and we're trying to come up with mathematical interpretations or ways of being able to achieve similar outcomes. And it just so happens that the way we're doing it now with machine learning is to effectively allow the computer to come up with the functions for us, is the idea. Similarly, a lot of people seem to think that artificial intelligence is about replacing human jobs and solely about automating as many domains as possible. But once again, that is not the case. Sure, one of the consequences of artificial intelligence is that we will end up replacing a couple of human jobs, right? That is fundamentally how technology works. When we advance, we're able to take away some of the more mundane and repetitive things that we do so that we are free to work in more creative domains that actually require our unique human skills. So we can stop acting as the infrastructure for our own industries. So technology can do that for us. That's always been our goal, right? But at the same time, machine learning is about a lot more than that. It's about enabling us to do things that we couldn't have done before, using the power of technology and this kind of really advanced data analysis. And at the same time, a lot of people also believe that it's about not just simulating, but surpassing human intelligence. But once again, one of the reasons I don't like to call this technology artificial intelligence is because that's not what it's about. It's not intelligent in any way. It's taking skills that we have as humans that we used to think require a kind of intrinsic intelligence capability and trying to simulate them without intelligence, trying to do them independently and mathematically. That is the idea behind this kind of machine learning technology. But of course, no matter how much you say it, it is really hard to keep that in mind because we're humans at the end of the day, right? Our brains have evolved, millions of years ago in the forest, in the wild, and we are not good at keeping in mind, for example, that a computer isn't intelligent, right? This is all relatively new stuff. We haven't had time to evolve to it yet. I mean, I'll be talking to a smart speaker, and I will understand how some people will have a difficult time keeping in mind that, for example, these personal assistants in your computers that you're able to quite literally talk to and have natural conversations with aren't actually intelligent. It sort of makes sense that your brain has that kind of bias. As a matter of fact, when I see news articles like this one, I'm really inspired to try and figure out a way to really get across the message of what artificial intelligence is meant for. For example, I saw this a couple months ago, right? It says, "Can artificial intelligence replace songwriters? A study on AI lyrics suggests it's possible." I saw this and I was immediately set on trying to come up with some kind of application, some kind of use case where I can prove how AI technology, as you might call it, is meant to augment human creative professionals, and in this case, specifically songwriters, and not replace them. That's the idea. That's sort of the mission I set out with. Now, of course, this is a really hard challenge. I knew this from the very beginning, right? Building a machine learning powered system to augment songwriters and help them in the creative process is a really big ask. And the reason for that is actually quite simple. And it's because natural language, and especially natural language in art, is orders of magnitude more difficult to understand than practically any other kind of data. Right, even just take a look at a simple verse like this one. Super simple verse from a song. Just understanding that second line requires all kinds of context and just knowledge that you take for granted. Right? Being able to understand that sleep is something that humans need and that this person's unable to sleep because they're saying about insomnia, and insomnia means that you cannot sleep. Why they have insomnia is a different thing that you need to relate to other sections of the song and even parts of this verse. Trying to understand that Tylenol is medicine. This medicine is supposed to help you sleep, but that it's not working. What does that mean metaphorically? There's all kinds of questions that you need to ask, and dependencies upon dependencies that are just really, really hard to fulfill. Right? You cannot implement this with like a symbolic reasoning approach. You can't do that with art, right? And precisely because computers are reliant on understanding things symbolically and mathematically, it becomes even harder, right? There's certain things that you don't think of intuitively that are actually challenges when it comes to trying to solve these problems computationally, right? Like, for example, in a verse like this one, if you were to actually listen to the song as a human, you would realize that the line break between the first two lines is only because there's a sort of pause in the actual melody of the actual rhythm of the song, right? There's a pause between those two lines, but they're conveying one thought. That's basically one sentence, if you will. But the line break between these two isn't because they're the same sentence, just split because of the rhythm. Instead, it's because we're starting a new context, right? That's a new sort of sentence, again, if you will, that we're starting within this verse. So even something as simple as taking the symbolic representation of a new line and assigning different meanings based off of context is something you've got to keep in mind. That's why developing these systems is so hard. You have to really remember that computers don't have the same kind of intuition that humans do. And you've got to code for all of those individual use cases and make it as easy as possible for the math to understand. And especially art makes it so much harder. With a traditional reasoning approach, you might say that a sentence like, or a line like this one doesn't make sense. How can you see things with your hands? But in the world of art, this can work, right? Depending on the message you're trying to get across, this can be totally valid, depending on how you want people to interpret what it is that you're singing. But I did set out on this journey, and I'm glad to say that I was able to achieve what I think is a really fun milestone, a project that I like to call Auto Lyricist, aiming to eliminate writer's block for songwriters through automated inspiration at scale, is what I call it. I've collaborated with a couple of artists, including the talented Claudia Heuser, a country singer-songwriter out of the States, and she recently published a song called A Summertime Song with lyrics written by Auto Lyricist in collaboration with her, using sort of getting across the message that she's trying to get across, right? The idea, once again, is for this to work alongside the songwriter. Now, I would be very happy to show you all a quick clip of the music video of A Summertime Song so you can take a look at this music. I do see my camera stopped, so I will fix that while you listen.
Replay it over all our favorite lines. It's never my intention to unwind. Loving you is like a summertime song. It goes a blazing past. Daydreaming a feeling I can't get back. Oh, summertime song. It's never my intention to waste your time. We jumped in the deep end and lost what I was hoping to find. Replayed over all our favorite lines. It's never my intention to say goodbye. Loving you is like a summertime song.
And there we go. Hopefully I'm back now as well. Unfortunately, technical difficulties do happen virtually. But anyway, I'm back now. And yes, this was a quick clip of a summertime song published by Claudia Heuser. It's actually on her debut album on Apple Music and Spotify and wherever else you listen to music. So do feel free to take a listen to the full version of the song. Once again, the idea, as I mentioned, is to augment songwriters using the potential of artificial intelligence. And as you can kind of imagine, Claudia was a little bit hesitant at first when I reached out to her to use the autolyricist system. As a matter of fact, how about we hear from Claudia what her thoughts were when she was first reached out to about using autolyricist or using AI for this kind of use case.
When I was first approached about this, I immediately thought, no way. When we're writing songs, I really try so hard to pull from my own experiences of people in the room, and just try to be as honest as possible. So thinking about a computer coming up with these ideas for me, I wasn't really having it. But I'm always up for trying something new. And what I realized was it was almost like working with an open-minded co-writer who just brought all these ideas to the table. And yeah, you could sift through the ones that were crazy and not going to work for you, but it kind of allowed us to think a little differently and took one of these songs that we had started in a completely different direction. So we were able to come up and find the line, "Loving You is like a summertime song." And now we have a brand new song that I just love. Hope you enjoy it.
That's the story. I mean, for me, it was really fascinating to see how Claudia went from, being hesitant at first to then sort of realizing the potential that this technology has to not necessarily take over the process, but rather to help, right? To augment songwriters. Now, you may know, if you've sort of looked into this domain, that there are already existing applications of machine learning in music. Google has Magenta, OpenAI has their Jukebox. There's all kinds of things that are trying to apply machine learning technology to in the world of music. But I find that in a lot of the cases, things are either limited because, first of all, they're dealing with music and not songwriting, which I believe is a much bigger challenge because then you have to understand natural language and music. Or a lot of them try and focus on replacing or removing the songwriter from the equation. And I don't think that's a valuable path to go down. Right? So for example, OpenAI Jukebox is designed to work as its own completely independent system. And as a research project, that's really fun. I want to see where that goes. But for something to actually be used in the real world, once again, the value of art comes from that sort of human creativity, human emotion, right? The sort of things that we invent, new things that we create. And AI can't replicate that today. I'll get deeper into why in just a moment. But once again, that's what sets this apart, is it's meant to work with the human instead of them, right? That's the entire goal. And speaking of replacing humans, when it comes to natural language generation technology like autolyricist, there's probably one application or one technology you heard of probably more than any other. And it's the OpenAI series of GPT, generative pre-trained transformer neural networks. Now, you've probably heard of GPT-2 and GPT-3, right? When either one of those were released, there was all this hype on the internet about, hey, neural networks can generate language like humans now. You may have read that famous little clip on GPT talking about why recycling is bad for the planet, or how folks in Argentina discovered unicorns. And of course, these are all like, machine generated articles. Like, people in Argentina didn't actually discover unicorns, if I have to specify that. But these are all machine written articles, and they sound incredibly realistic, right? And so you see all these different news articles, like, for example, The Guardian publishing, hey, a machine learning algorithm wrote this entire article about artificial intelligence taking over the world. But then you start to take a look at the tiny little footnotes in the legal fine print, and you start to realize that it's actually a bunch of different AI generations that were manually human cherry-picked and sort of stitched together into a neat article format, right? And so, a lot of people sort of don't realize the truth behind what artificial intelligence is genuinely capable of and where it's meant to be applied. And B, a lot of different folks sometimes actually do publish sometimes intentionally misleading sort of articles or publications about what AI is doing, right? And a lot of it is to sort of capitalize on the fact that that a lot of people don't understand what this AI technology is meant for, right? So GPT-3, for example, as I mentioned, a lot of the hype on the media is very much unjustified, right? It's not real. But that's not to say that it's not useful technology. I've personally used GPT-3 as a wonderful drop-in replacement for many different neural networks, and it's orders of magnitude more powerful than any of the other ones before it. However, it has its use cases. It's not universally applicable and suddenly going to replace humans from, songwriting and the coding fields and journalism and so much more, right? That's not what it's going to do. That's not what it's meant for. Once again, though, as I mentioned, it has its use cases. For example, going back to this quote that I was talking about earlier today about why machine learning is such a disruptive technology. The reason I didn't tell you who said this is because this actually isn't from a person. This is GPT-3's explanation of why machine learning is such a disruptive technology, right? That is absolutely fascinating to me, that this neural network was able to come up with this kind of reasoning, and it is not plagiarized, right? This is not something you can find on the internet. It is a unique sentence, but what's important is that this reasoning isn't new. This is something that people have been saying in other ways for a long time. It's coming from the same data set that GPT-3 was trained on, the internet. It's just the way that that thought was represented is new. And that's why I say that machine learning algorithms aren't here to replace creative professionals, because they don't have the same kind of creativity we do. They're not coming up with new thoughts. They're coming up with new ways to represent the same thoughts that they've always been fed. Because once again, neural networks just boil down to simple data analysis. As a matter of fact, I do want to dig a little bit deeper into that and how deep learning actually works. Because if you think about natural language processing, the way that we do it as humans is, of course, you hear a sentence or you see a sentence like this one, colorless green ideas sleep furiously. Your brain represents this in some way. How it represents this is incredibly complicated. We cannot understand how exactly the brain decides to represent this in your head, right? We cannot take your brain's representation of the sentence and export it to a mathematical vector. We can't do that yet. We don't have the technology. We don't understand how the brain works well enough. And so what we try and do as researchers, of course, is we try and apply deep learning technology to try and save us here, right? We try and apply deep learning to make it so that we can have the computer come up with a mathematical representation of these sentences, so we don't need to. But that does beg the question of, well, how does deep learning work? Right? How do we use technology to figure out these representations for us? And the way I like to think of it is actually really simple. It's like this. I like to refer to the joke of a topologist can't tell the difference between a coffee mug and a donut, right? Because, of course, a coffee mug and a donut both only have a single hole. Right? So a topologist did the same shape. And the reason that I think this is a really good analogy is because think about it like this. Imagine you've got a coffee mug and you draw a bunch of random blue and red dots on it, right? If I were to ask you to draw a single straight line on this coffee mug that could separate your blue and your red dots, it would probably be difficult because there'd probably be a lot of sort of like intersecting, dots, and drawing a single straight line to separate them probably wouldn't be possible. But what if you really wanted to do that? Well, maybe you could take the coffee mug and you could actually change the actual space on which these points are drawn. You could form it into something else, like a donut, in order to create a new space where the dots are actually separable. And so what you can do is you can warp the space in which the dots are located such that within this new space, you can draw a single straight line to separate them. And that is the core of deep learning. That's pretty much all there is to it. Right, at least the vast majority of modern deep learning applications. For example, take a look at this data, right? You've got 3 different clusters, and using just straight lines, you could pretty reasonably separate between them, right? Red's super easy. Green and blue, you could probably separate between them reasonably well, right? Maybe I can see like with a single straight line, like one misclassification on either side, right? But this is not the original data. The original data is the one on the left. And as you can tell, a single straight line between green and blue on the original data would result in way more misclassifications than the one on the right. And so using deep learning technology, you can learn how to transform the space in which your data is located such that it's easier to operate on your data. That is effectively what deep learning boils down to and is the core behind all these modern AI applications that you see. And the way that this works, sort of the way that you can think of it intuitively, is, for example, if you had a picture of a cat, or you had pictures of cats and dogs, and you wanted to train a neural network to predict, given an image, is this an image of a cat or is this an image of a dog? You could feed this into a deep neural network that then exports its data into a single sort of linear classification layer, and then outputs a probability for cat and a probability for dog. And not because you specified it, but just because of the nature of the optimization algorithms that are used to train these neural networks, what you will end up doing is training a mathematical function to take your image and to embed it into a very large dimensional space where individual sort of clusters represent what the type of image is. And that final linear layer, all it's doing is it's separating between those clusters in order to classify between your different kinds of expected output. That's really all there is to it in the end. And the reason that this neural network learns these things is because of the training objective that you feed it. In this particular case, the training objective was, given an image, give me the probability distribution against cat and dog. That's all there was. And just because the simplest way to do that was to make cats and dogs linearly separable in some arbitrary space, that's what the neural network ended up learning. But there's also other ways you could train, right? There's other training objectives you could give. For example, you could show it 3 images at a time, and you could make it so that 2 of them have closer points in this space, and 1 of them against the other have further away points in this space. This will also end up creating 2 separate clusters that are likely linearly separable that you can tell the difference between. But in this case, you didn't even need to tell it which image was which. You just told it, these 2 are similar, these 2 are different. Figure it out. Right? That's the fun behind this math, is that you can optimize against arbitrary objectives as long as they're differentiable. As long as you can calculate a derivative through that function, you can optimize a neural network on it. And the reason that I highlight this, the reason that I think this is really important, is because training objectives are all around us, right? And no matter what the entity is, could be a neural network, could be humans, we will always try and find the simplest way to achieve a training objective. For example, this is actually one of my favorite examples, an article from one of my friends, Timothy Duncan. He wrote this some time ago. It's called A Tale of Two Police Departments. And it covers sort of the state of the police and police departments in the US. It talks about how they were incentivized for the war on drugs to just create basically as many arrests as possible. And you can kind of see where that logic stems from. But the problem is that humans are very greedy optimizers. Regardless of what the intention is behind an objective, we will always try and find the simplest possible way to achieve an objective. And as you can probably tell now, this objective was pretty fundamentally flawed. So what's really important is to keep in mind that when you're creating an objective for humans or for neural networks, mathematically, if you have the wrong training objective, even if it makes sense to you intuitively, it could always end up not exactly working out the way you expect it to. And so that's why it's really important to keep in mind that what you're training your neural networks to do is always the key. That also brings us back to creativity, right? One of the reasons that I do not believe machine learning technology is creative or can replace creative professionals the way that a lot of people don't believe it to, at least modern machine learning technology, is precisely because of the fact that, well, our training objectives give them no incentive to learn creativity or intelligence. Right? Language models are only trained to predict the next sequence in a token, next token in a sequence of words. Right? They're not trained with the objective of being able to have long-term coherence or being able to understand anything about the world. As a matter of fact, there's a quick demo I want to show you of a neural network that I've built to sort of show you what things these neural networks learn. This is actually code available on my GitHub, so I will go ahead and post a link to it in a bit as well, so if you'd like to take a look. But this is actually relatively simple code. You may have seen something similar in just about 43 lines of code, and this could be even shorter. I'm able to train an entire neural network to about 98% accuracy to determine the difference between cats and dogs. This is fine-tuning an existing neural network called ResNet50 that's available for you to use using the Keras framework, specifically TF.Keras, TensorFlow.Keras, right? So this code enables me to train a neural network to tell the difference between cats and dogs. And what I really want you to notice is that all we're doing here is effectively compiling this model and fitting it on data that teaches it the difference between cats and dogs. That's all. That's the only thing it's trained to do. But at the same time, if we take a look at this code, what I'm doing here is actually removing the last layer of this model where it gives me that probability distribution of, is this a cat or is this a dog? I'm removing that last layer, and then I'm running more predictions to get the penultimate sort of representations of those images through the neural network. And if you plot out those representations in 3 dimensions, you actually notice what I think is a very interesting pattern. You start to notice that if you give this a second, you'll see, as you can tell, we're at about 98.3% accuracy on the testing set. But if you actually plot out that sort of second last layers outputs, you notice that at the very end, what the neural network has effectively done is it's embedded those cats and dogs into this space where they're in their own clusters. Right? The red dots are cats, the blue dots are dogs. The neural network, without ever having been told to do so, just because it's mathematically the simplest way to achieve the objective that we defined, figured out a way to create this space in which cats and dogs are naturally separated based off of the transformations that came before them. Millions of transformations, if I may add, before them to result in this space. That is what's so that's what's so powerful about these neural networks, is they're able to learn these arbitrary transformations without us having to manually figure out how to do those transformations, because we can't. Right? We don't understand the brain or the way that we do these things well enough in order to do so. But that is a quick demo of neural networks actually learning these representations. I find it incredibly exciting that we can do this. And really quickly, before we transition into a Q&A, because I'd love to go ahead and answer your questions now. I know we're sort of nearing the end of our time. I do want to say one more thing, and that is that really my goal has always been to highlight how we can use technology to solve problems. Right? As you can probably tell, I'm really passionate about identifying problems that people have and then being able to use technology to work towards solving them. And that's always the goal. Start from the problem and then figure out how technology can solve it. And I find that especially with technologies like AI, a lot of people think, AI is really fun. What can we do with it? But rather, I think the way you should think about it is that AI is just another tool in a developer's tool belt, right? If you see a problem that can specifically be solved better using the power of AI, go for it. Super powerful. But a lot of people think about AI or technology first. I think it should be the other way around. I think we should be looking at the problem, trying to figure out how we can solve it, how we can add value to people's lives using the power of technology, and sort of solve more problems we couldn't have solved before with the power of machine learning and deep learning technology. And so Thank you very much for joining. Once again, the code that I showed is available on GitHub for you to take a look at, and I'd love to show you whatever else it is that you'd be interested in, and also answer any questions you may have. So let's go ahead and get started with the Q&A then.
Yeah, we had a couple questions. So one of them was about like what sparked you to help songwriters to use the auto lyricist system, and also when will people like customers get hands on that technology?
Wonderful. No, glad to answer that question. As I mentioned, it was really specifically seeing how people were talking about how technologies like OpenAI's GPT-3 are going to replace, I mean, as I mentioned, journalists, developers, songwriters, and just so many other domains. Basically, just insert random field here, right? There was a news article for basically every domain about how OpenAI is going to be replacing them, and that's not true, right? A lot of people are really overhyping this technology, is what I thought, and so I thought, can I come up with a use case showing how machine learning really adds value to creative professionals instead of replacing them? That was sort of what inspired me to get started. And of course, the fact that I find it really fun building these sorts of machine learning tools. Because I mean, how isn't it fun to have a machine learning system that can arbitrarily generate lyrics when you want it to? And of course, that's sort of what initially got me started. I'm currently working on refining the technology, integrating newer sort of forms of neural networks and sort of discrimination techniques to find high quality generations. That's something that I'm currently working on, actually working with a couple different artists too, on sort of, fine tuning the technology a bit more. Once it gets to a stage where it's a bit more reliable, is something that I plan on releasing as an application that people can use more widely. So I don't have a concrete timeline for that just yet, but sometime within the next couple of months, you should be able to use your own version of Auto Lyricist.
That sounds great.
Thank you.
And then another question is, where do you see yourself 5 years from now? / what are your goals for 2022?
Totally. 5 years from now, really hard to say. I'll say that because the field of technology moves too fast, I think, now to be able to even say, this is what I definitely plan on doing 5 years from now. In terms of goals for 2022, and I'll sort of get back to the first question. In terms of goals for 2022, really, I plan on doing a couple different things. One of the things that I'm actually currently working on is I'm the application architect for DB2 at IBM, and so one of the things that I've been working on recently is brand new database connection technology. I can't say much more about exactly what it is we're doing just yet, but very soon I will be working on new and innovative ways for you to store and access very large amounts of data in an enterprise-grade sense. I think that's really exciting technology that's coming up soon. It can help you with your machine learning work and can help you with all kinds of workloads, really, and I think that's really fun. As well as working on brand new machine learning technology, as I mentioned, working on Auto Lyricist, fine-tuning that system, and also getting this technology into the hands of more developers is something that I'm working on this year. And so again, while I can't say too much about exactly what it is that I'm working on just yet, there's more coming out this year when it comes to sort of my technology in the world of machine learning and also data in general. That's coming soon. But yeah, 5 years from now, really it's scaling up the initiatives that I have, right? So writing more books, being able to help more developers, doing more talks like this one, answering questions, and really working towards solving problems with the power of technology.
Definitely sounds like you have a busy year ahead of you.
It's definitely going to be fun.
Yeah, some people were actually really interested in seeing like if you can demo a little bit of the code that you use for Auto Lyricist, or just talking about like the coding process and all that.
Sure. I can give you a high-level overview of the actual process. Unfortunately, I'm not sure if I can spin up the actual Auto Lyricist system as of right now. But a high-level sort of overview of the way that it works, which I think is a really interesting architecture, is there's sorts of 3 stages to it, right? Because the way that Auto Lyricist works is that you're not just supposed to generate lyrics, right? You're supposed to base them off of existing content, because that's the idea, right? To help songwriters. So let's just say someone's written like a verse or a bridge and they want to come up with a chorus, right? Auto Lyricist can sort of take existing content and help you generate basically infinite amounts of new content in order to sort of take inspiration from that new content for songwriters. So that sort of means that in 3 different stages, right? Of course, the first and most important stage is actually generating lyrics, because without that, there's nothing else I can do. That is actually incredibly difficult, and one of the largest challenges I had was finding data, because oh boy, is finding data difficult for this. So the way that I've decided to do it is actually to scrape the Genius website. But even Genius, the site where you can get music lyrics, is very unstructured, right? Some songs are structured in a relatively formatted way, or formatted in a relatively structured way. Others are incredibly unstructured. Some songs are in different languages. Some of them aren't tagged correctly. It's a mess. And so one of the largest challenges for me was actually collecting that data. Once I had about 4,000 songs that I could reasonably confidently say were clean pieces of data, I was able to go ahead and train a GPT-2 large model to generate lyrics, which is something that a lot of people have done. But the next two stages are what really set the system apart, right? So once I've got this neural network generating music lyrics the way that I want it to, the problem is that, once again, neural networks aren't trained for long-term coherence. A lot of the time, they'll go on rambling about something else. They won't make sense anymore because they've lost context. It's weird. And so the next two stages do what I would call like a discrimination stage, as well as a relevance scoring stage. So one neural network's actually responsible just for predicting, given a verse or a chorus or whatever, did this come from the neural network or was this human written? Right? And what I then do is I take millions of generations from GPT-2, and I keep only the ones that this neural network thought were human written. Right? And what that enables me to do is cherry pick what the neural network thinks are the really good lyrics, and then try and score their relevance to the input. Right? So if you gave me a verse and a chorus and you try to generate a bridge, this neural network is responsible for predicting, hey, do these bridges make sense in context of the verse and the chorus that were fed in? Right? So then using those as scoring, and then using a little bit of a reinforcement learning algorithm to figure out heuristics, to figure out, when is quality versus when is relevance important, I'm then able to come up with a ranked list of a bunch of different verses or choruses or bridges or intros or outros or whatever you want for your song. So unfortunately, while I can't pull it up right now, eventually you will be able to take a look at all the different stages. So make sure you keep an eye out on my social media and GitHub for when I do eventually release that.
Yeah, and we'll make sure to put it on our school's Discord and our socials as well. So stay tuned. We have a couple more questions actually.
Mhm.
So when you were working on the Heart ID project, did you face any issues of data disruption, as the heartbeat of a human in colder regions is a bit faster than people living in warm regions?
That is a very interesting question. I guess sort of to generalize it a bit more, apart from just the sort of temperature of the region you're from, heart rate in general actually doesn't affect the neural network, funny enough. And the reason it doesn't is because the network was trained on multiple different heart rates, not just a very controlled environment. It was trained on heart rates that varied from very slow to someone that was angry, someone that just exercised, someone that's been relaxing for a while. It was trained on all this different data, and it was able to sort of learn how to abstract away heart rate to only look at the patterns in the actual heartbeat. For example, one of the differences between different heart rates is, I believe it's called the T wave on the electrocardiogram, actually shifts to the left or the right based off of your heart rate. But that's actually a wave that the neural network, if you look at the weights, has actually learned to ignore because it knows that it shifts around a lot, right? So it sort of, once again, because of the training objective that I was talking about, it was able to learn to ignore parts of the heartbeat, to only look at the parts that are actually agnostic to, for example, the speed of the heartbeats. So luckily, it does work across multiple different regions. I will say, though, actually a pretty funny story. I was demoing Heart ID in Vienna once, and of course, I live in Canada, and I was demoing it in Vienna, and I flew over from North America to Europe for that. Problem with that is that electrical frequencies in North America are different from the ones in Europe. And for the longest time before my keynote, I couldn't figure out why the data was just so noisy in Europe, before I realized that, hey, the bandpass filter that's responsible for moving 60 hertz here should be removing 50 hertz in Europe. Oh, you can see me. Oh, there we go. Should be removing 50 hertz in Europe. And once I figured that out a couple hours before my keynote, I was super relieved that that was actually working. But apart from the electricity bands, everything else should work with your heartbeat.
Well, I hope that answers your question, Shiva. Yeah, and then another question is, much like musicians who work in groups, do you think that multiple AI applications working together could collaborate to create more complex and interesting music?
Yes. However, this is already a sort of technology and approach that has been studied. It's called ensembling models. As a matter of fact, one of the ways you can do it is called a mixture of experts model. Effectively, what that does is it takes multiple different machine learning models that may have learned their own independent things, and effectively uses another machine learning model to look at outputs across them and sort of come up with outputs depending on what the previous outputs were from those machine learning models. The reason that I don't use it for auto lyricist is because at the time of building the original version, at least, there was only one really competent neural network for generating language. And generally, if you have multiple different machine learning models and they're all trained with the same training objective and they're all the same, even though they're trained separately, they usually end up converging to similar weights. So a mixture of experts model wouldn't really add much value except taking a lot more compute. And so I didn't use it for auto lyricist. However, now that there's a lot more variation with the way that different models deal with language, that is absolutely something I could look at. So that's a good question, Luke. We'll take a look into that.
We have two more questions and then we'll wrap up for today. So Hamad asked, deepfake seems like a big problem in the future. How do you think machine learning and AI can counter the very problem that it created?
That's a really great question, and I'm glad that you brought up using machine learning to counter it, because a lot of people, like to focus on, hey, machine learning gives us really powerful capabilities that can be used for obviously the wrong reasons. And what is important to realize, I think, is that all technology is really powerful when that technology is released to be used for the wrong reasons. But we are also able to use that technology to counter those wrong reasons, right? And so deepfakes, for example, classic example, we've got neural networks from DARPA, from Facebook, or now Meta, that are able to realize when videos are fake. This is a pretty well-studied domain. As of right now, neural networks are pretty good, but they're definitely not foolproof when it comes to generating fake content. It can look incredibly realistic to the human eye, but still be detectable from a machine learning perspective because of, once again, the sort of minute signature that these deep learning-based techniques add to the video. You may know, for example, that it's possible to trick neural networks with what are called adversarial examples, where you basically take, individual pixels and just swap tiny values here and there based off of the weights of the neural network, so that humans cannot tell the difference between the original image and the changed image. But according to the image, a school bus might turn into an ostrich. According to the neural network, a school bus might turn into like an ostrich, just because of a few pixels being changed in just the right way, right? Because of these very weird quirks of neural networks, because of, once again, the specific mathematical, training objectives that they have that really don't incentivize them for real intelligence. They have these sorts of weird signatures of, patterns that they put onto the data that they generate that are detectable. Whether it's something more obvious, like the way that the eyes move or close, right? Because that's relatively hard for these deep learning systems, or even if it's something a lot more minute that we couldn't even describe that other neural networks are able to pick up on. Most of the time, we are able to figure out these patterns just because of the fact that deep learning systems work the way they do, right? So using machine learning, we have already been able to build systems that can detect deepfakes very reliably, and we're going to continue to do things that are similar to this. Even MIT and IBM Watson's research lab having created a neural network that can detect when text is GPT written or not. So it's pretty incredible, the kinds of anti-fake data technology that we have. So it's definitely a field that gets a lot of attention.
That's actually really cool to hear. I definitely didn't know that. Saurabh asked, where would someone go / what resources can you use to learn more about machine learning?
Mm-hmm. So I would absolutely recommend, I would say it depends. For most people that are sort of developers and you know how to code and you want to get into the world of machine learning, I would recommend starting off with resources like, for example, Cognitive Class is a good one. It's a course platform where you can take a look at courses on all the way from learning Python to learning how to use different big data and machine learning libraries in that language, including R, and Swift for TensorFlow even is actually one of the courses that I have on there. And I know a lot of the folks that have made the other courses on machine learning, and I can say they're really interesting courses, as well as My YouTube channel is another one. I have a Learn Deep Learning from Scratch series where you can get started learning about machine learning, gradient descent, so much more. So do take a look at that, as well as I know Coursera has a bunch of different certifications and sort of learning paths where you can learn machine learning technology. One more thing that I would also recommend, and this is something we were talking about a little bit before, is it's really effective to learn from experience, right? I've personally found that I learn the most when I'm building things, right? Recently, I've had to learn, or recently I've wanted to learn the Rust programming language. I mean, it's something that I've been wanting to do for 2 years now, but I only finally got to doing it, and I found just watching videos or like reading documentation isn't as helpful as just saying, let's build something, right? So, whether it's building my 2048 game that I built in Swift in Rust, it's actually really fun. It's actually the world's fastest 2048 bot that's been written. The Rust version gets something like 14,000 moves a second. So yeah, really learning from experience, I think, is really important. So whether that means you going to the Google Dataset Explorer and figuring out random data sets that you can build machine learning algorithms with, or whether that means going to Kaggle and participating in random competitions, not even necessarily to win, just to learn, right? To be able to get access to data and use cases, and being able to train using resources like Google Colab. If you've got one of the new Apple Silicon Macs, using the new Metal for TensorFlow, bindings, however it might be, being able to get real experience, I think, beats any sort of more structured way of learning. Of course, that is important. That does have a role to play, but make sure you're actually building things and not just following existing resources is what I'd recommend.
I'm just going to squeeze in one last question here. Someone asked that since you've worked in many domains of machine learning, what's the one thing that you're really interested in and you'll be focusing on in the upcoming future?
So I would say that the two things I'm most interested in would be, in general, as I mentioned before, working with language, being able to understand and specifically generate it, because once again, that language is very intrinsically tied to thought. And it just so happens that with practically every language task that requires thought, neural networks don't perform well, right? Think about translation. Translation's super easy for machines today because it requires no thought. The thought is already created by humans and represented in language. All it needs to do is understand the thought and translate the thought. Super simple. But when it comes to, for example, given 4 words like dog, ball, park, right? Or 3 words in this case. So given 3 words, can you generate a sentence? That requires a lot of thought. That requires creativity. And neural networks are simply incapable of this at this point. I'm really interested in coming up with ways to solve that problem, and to be able to work with language with higher levels of fidelity using machines. I'm also really interested, though, I would say, in the whole understanding how we can get machine learning algorithms to learn more flexibly. Right? Because right now they're quite rigid, right? The really, really sort of robust, enterprise grade ways of learning for deep learning algorithms are all gradient descent based, right? They're all based on using differentiable functions to optimize a very well-structured function. I'm very interested in finding new ways to, for example, use reinforcement learning or evolutionary technologies to be able to create more flexible training objectives, which of course is sort of the whole challenge, right? If you can create more flexible training objectives, then you can do all kinds of things. You can solve all kinds of problems that you couldn't before, right? So that's definitely something that I'm very interested in.
Thank you so much, Tanmay, and thank you all for tuning in. On behalf of Carleton University's Google Developer Student Club, we thank you all. Make sure to follow us at GDSC Carleton on Instagram, and hope you all enjoyed.
Thank you.